In this session, I will show you how to build a Reaction Plan Manager++ solution. If you do not know what a solution is, view the Reaction Plan Manager++ solution video. I also suggest you view the Setup Reaction Plan Manager++ video. Developing a solution is pretty simple. You start with a data file. RPM++ is designed to always react to data. So the easiest way to build a solution is to simply place a data file in the trigger directory. If the automatically build a solution when one is not available setting is on, then a solution will be created automatically. If this setting is not on, or for other reasons the software cannot automatically build a solution, then a solution folder is open with the data file moved to its location in preparation for you to build a solution. You will see a message with some general instructions telling you what happened, and it's ready to build a solution. I'm going to demonstrate both methods for setting up a solution. First thing I'm going to do is check my settings to see if I've got the auto solution builder turned on. And here you can see I've got the automatically build a solution if one is not available checked, which means if data appears, Reaction Plan Manager will try to automatically build the solution if one is not available. I'm going to use a data simulator to create data files. Now notice I left this window open so that my automatic data monitoring is paused. That way it doesn't just automatically create the solution right away. I'm going to go ahead and hit the inspect button a couple times, switch from machine A to machine B, hit the inspect button a couple more times. So now if I click on the Done button, it'll turn the automatic data monitoring back on and a solution should be built for me. So let's see what happens. And that's exactly what happened. A solution to process write new-t.csv could not be found, and one was automatically built. This will get you about 90% of what you need to complete a solution. But obviously we need to do a little bit more work. You'd have to go to your data collector and set that up so you group the data accordingly, and you would customize your dimensional items to react to the data appropriately, and possibly add some pictorial content to make it clear for the operators. Before jumping into the data collector, what I want to do is show you what happens if you don't have the auto solution builder turned on. So here I'm going to go to the edit mode, and I'm going to click on new to clear out what's in memory. I'm going to go back to the view mode, go to about, and this time I'm going to go to settings. I'm going to turn off the automatically build a solution if one is not available. I'm also going to delete the folder which contains a solution that we just built. So now there should be no solution for the write new-t simulation. So let's go ahead and do the same thing. I'm gonna pump in some data, create that data file. Let's give me some A's, some B's. Okay. Now if I click on Done, I get a different message. It says a solution to process write new-t CSV does not exist. The folder write new-t data was created and the data file moved to its location in preparation to build a new solution. Choose the Edit button, then use the editing tools to build the data collector and design a reaction plan. So I say OK. The solution to process write new-tsv t-t.csv could not be found. So it's a different path. A solution folder was built. As you can see here, the write new-t data, that folder was built. It just did not build a solution for us. So now we have to manually go in and set up the data collector and add the dimensional items and the pictorial content to finish up this solution. It doesn't matter whether you are using the Auto Solution Builder or not. The next step is to configure the solution's data collector. The data collector determines how the measurement data is read from the data source, grouped, and distributed to the reaction plans. So right now I'm going to click on the Edit button. I'm going to open up the Write New-T solution. Notice I get this message: the solution's data collector cannot be found. Reaction plans cannot be developed without first configuring the data collector. The data collector determines how data is read, grouped, and stored. And I'll say OK. And now I'll get another message here saying the data collector has been configured using default settings. If you need to isolate data streams, in other words group the data, click on the Filter tab and add filters. Filters are used by the data collector to group data. I'll say OK, and now I'll work on the data collector. Let's talk about the data collector and see what it looks like. Well, the data collector, you can see we have three tabs. You have the General, Filter, and Configure Data Collection tab. The General tab gives you access to tools where it lets you define exactly how to read the data file. I can play the solution to simulate data flowing through the filters and being sent to a reaction plan. This is useful for testing purposes and to do quick checks. The Filter tab allows me to have access to tools to set up the data groupings, and the Configure Data Collection will let me identify a column which has a unique marker used to keep the data. If I left this field blank, the data would not be kept, it would just be discarded. Well, let's talk a little bit about this portion of the screen. Notice I've got some records that are marked in green and others that are white. I've got a little, there's a little discoloration here to note the end of the data. This table looks kind of like Excel, but it's really not. The actual records down here that are white, there's actual data in here, you just can't see it because the columns aren't big enough. I'll just open up some of those columns so you can see. Now the way the data is organized, the latest data is at the bottom, and as it goes up, it's older data. So the most current data is at the very bottom. In this particular case, the header records, or the green records, include the nominal, plus, and minus tolerance. So at a glance, I can tell you that this column is the name of the feature is an X dimension, it's 1x. The nominal is 4. The plus tolerance is 0.006, and the minus tolerance is also 0.006. Now sometimes you don't have this information. That's okay. When you configure your dimensional items, you can include that in the dimensional items. I need to click on the column A here to set my keep data column marker back to the timestamp. If you need to, sometimes you can put a comma in here, A, comma, B, comma, C, and it'll use a combination of all three columns to figure out what data it has read and what data it has not read. Now I'd like to set up a filter so I can group my data by machine. Now here I'm going to use this slider bar. I'm going to slide across to find the column that contains the machine filter. So here I can see, here's machine, I've got machine B, and I've got machine A. I want to organize that into groups. So all you got to do is here in the filter button, filter tab, click on the column containing the filter, and here you can assign it a name. Here I'm going to put in the word machine because that's the name that I want to assign that filter. Click on add, and I've just added a filter. So now Reaction Plan Manager++ will group the data by machine. To test the filter, simply click on the General tab and click on the play button. When you click on the play button, it'll read the data file and try to figure out how to filter it. To figure it out, it looks at the last record to decide how to group the data. Since if I look at sheet 2 contains all the records. If I go to the end and I look at my machine, the last record read was machine A. So sheet 1 will contain all of the records for machine A. So if I look at sheet 1, slide over, you'll notice that all the records are only for machine A. Now clearly I've got machine B and machine A, so in real life when you run this, I'd end up with two reaction plans or two groups, one containing all the B data and the other containing all the A data. That's all there is to developing the data collector. We know that the data collector will read the data and pump the data to the appropriate reaction plans. I haven't talked much about reaction plans. Here on the left-hand side, this bluish colored panel here contains the available reaction plans. Now right now we only have one reaction plan. It's called the offline plan. That's because we haven't saved the solution nor have we processed the solution. So if I save the solution, you'll get this message. The template page is a reaction plan with no data. It is the initial reaction plan to build all other plans for the solution. Since the template page was not located, it was created from the offline page. So here you'll see we have an offline reaction plan and a template reaction plan. The template, as that prompt, as that message said, is basically the building block for all the other plans. When data flows into the solution, if there is no reaction plan associated with the data set, with the group data, it'll use a template plan and build another reaction plan. The offline plan is kind of like a working plan. This is the one that if I click on the play button in the data collector with that little check mark by the play button, it'll pump data to this offline plan. This is used to experiment with data and to perform some tests. As we process data, this list will grow based upon the unique streams or the unique groupings from the data collector. A question you're probably asking yourself is, what happens if I edit or insert a dimensional item? For example, right now my offline plan is active. If I insert a dimensional item, does it insert it into the offline plan only? Or how does that work? Well, when you insert a dimensional item or edit or delete a dimensional item, it will affect all the plans. So if I insert a dimensional item, it'll insert the dimensional item in all the plans. If I move the dimensional item up or down, it'll move the dimensional item across all the plans. There are exceptions to that, and I'll get into that into those exceptions later. So I'm going to go ahead and insert a dimensional item. Use this button up here to insert the dimension. I'm going to slide this window over so we can actually see the dimension. Okay, I've inserted a dimension. I've not configured it yet, but I've inserted it. Now if I click on the template reaction plan, notice I now have a dimensional item here. So whether I'm in the offline or template, I can go ahead and make modifications to this dimensional item. I'm going to quickly configure this dimension item, and then we'll run data through the solution so you can see the reaction plans appear and see how the solution behaves. So I'm going to expand this a little bit and quickly fill this out. We'll call this tool 1. No adjustment required. And I'll leave the rest of this alone. Tell it where there's some data. set this up so that we're using 80% of the tolerance. And just fill this out real quickly. Now I'm going to save this dimensional item. And we'll go ahead and save this project. Now I'll open up my data simulator and we'll pump some data in here. I've got some machine A's, some machine B's, and some machine C's. Now I'm in the edit mode, so it's not going to process any plans because I'm in the edit mode. Now if I go to the view mode, it'll ask me if I want to save this solution. I'll say yes. Now it'll find that data and process it. Now notice here I have 3 plans that are displayed: machine C, machine B, and machine A. Since we're in the view mode, the offline plan and the template plan are hidden. They're in the solution, they're just hidden because we don't want to see it in the view mode. We just want to see the process plans. And now I can bounce back and forth from one plan to the next plan. And of course I've got a flag by each plan to let you know that new data appeared. Now if I now just run machine A, inspect some data, you'll notice the flag now only shows up on machine A because machine A received the new data. If we go back to the edit mode, now notice we have offline, template, machine C, machine B, and machine A plans. In this session we discussed different approaches to building a solution. We built a solution using the Auto Solution Builder and made one from scratch. You understand that RPM++ always reacts to the data, so you simply drop a data file in the trigger directory to start the build process. You learned how to configure the data collector and how reaction plans are created from the template plan. You were also introduced to the dimensional item. Dimension items are the key to analyzing data. I suggest you view the dimension items video next. Thank you.